So what is UTF-8 and how it is encoded? See, UTF-8 is a way to encode the Unicode values, and the word character will be referred to the value of the character in Unicode, which goes from 1 to 112064, and say from the values which can be, or the characters which can be, or the symbols which can be given sub code, so which can be used as a string terminator. This 0, this can be used as a string terminator, and how we have come to this number you will shortly be knowing. So UTF is a variable size encoding, means it will the UTF characters will code into either 1 byte, 2 byte, 3 byte or 4 byte. So 1 byte means 0 to 127, meaning if it's 1 byte encoding, it will be equivalent to exactly what ASCII is. ASCII. 2 byte encodings are for all the characters from 128 to 2047. The 3 byte is from 2048 to 65535, and these numbers you will shortly be knowing how this number has come up. And the 4 byte encoding are the characters from 65536 to 112064. So how does it work? We need to understand the binary representation of each character's numeric value. So just to understand that a 4-bit nibble is a hexadecimal notation. So we'll see how. Just have a quick look on this table, because we are going to use it while I'm going to explain you what is exactly going on in Unicode. So if this is a binary, say 11 in binary is 1, in decimal is 1011 in binary, and which is B in the hexadecimal. For example, if I write 2C, 2C is what? 2 into 16, 16 to the power 1 plus C, C is that is 12, C, take C, C is 12, 12 into 16 to the power 0. So this is what? 48. And the binary equivalent is nothing but 0010 and 1100. If you divide it by 2, take the remainders and take in the reverse order, you will get this. So this is how we are going to see, because these are the numbers we are going to just write directly. So this is just for the beginners who don't understand these things. So UTF-8 format, the higher order bits are in binary. These are very important, because UTF-8 this works by using the leading higher order bits of the first byte to tell how many bytes were used to encode the value. For example, for 8-bit encoding from 0 to 127, the higher bit will always be 0. Because of this, if the higher bit is 0, then the byte will always be treated as a single byte encoding. If the first or the higher bit of a byte is 0, the byte will always be treated as a single byte encoding. Say of this form. Say this is 0, and it can this can be anything, any combination of bits. These bits, so there are 7 bits which are available to code the number. Let us see the format of all the codings. This is a 1 byte coding. In Unicode UTF-8, this is a 1 byte encoding. Please see this 0 is fixed. The high order 1 will always be 0. The other bits are used to encode the characters. These are all the 7 bits remaining which can be used to encode the character. That is why I am saying the 1 byte encoding of Unicode is exactly similar to the ASCII. Then 2 byte. 2 byte encoding, the first 3 bit or higher bit is always 110. This is 110. This is fixed. And the second byte, because we are talking about 2 byte, this is first byte, this is your second byte. So the first byte, the higher order bits are 110 fixed. The second byte will have 10 as fixed. The 2 higher order bits of the second byte will be 10. So this gives how many? We are left with 5 here and 6 here. 5 plus 6 is 11. So we are left with 16 bits to encode the actual character. So we are left with 0 to 2 to the power 11 minus 1. From here, the number have come up, which I actually indicated you earlier. Now when we are dealing with 3 byte encoding, this is your first byte, this is your second byte, and this is your third byte. So these are the three bytes. So the first 4 higher order bits of the first byte are set to 1110. See, these are set. You cannot change it. This is what the Unicode consortium has done. The second byte, the first 2 higher order bits will be 10, and again 10 will be the third byte, the high order bits. So what we are left with, this is 4, this is 6, this is 6. So that will be 6 plus 6 plus 4, that is 16 bits. So the actual character can be coded into 0 to 2 to the power 16 minus 1. Okay, these number of characters can be encoded. And finally, the 4 byte encoding. The first 5 is fixed, 111 111 10. and this again 10 10 10. So how many are we left with for 4 byte? The first 5 higher order bits of the first byte is fixed, 1 1 1 0, here 1 0, here 1 0, here 1 0. So 3 are left, 6 6 6 6 3 is 18, 18 plus 3 is 21. So we are left with 21 bits to encode the actual character. So how many characters we can encode? 0 2 2 to the power 21 minus 1. These are the numbers. So 1 1 2, I hope you remember that number, that has come from here only. So once you know the format of this UTF-8, you can just convert it back and forth. It's quite simple. Just you have to convert UTF-8, you have to encode it, you have to see that it will be encoded in 1, 2, 3 or 4 bytes by just checking the numerical range, and then you have to just copy the bits to the correct location. Let me give you an example. So let us take an example. We are going to use hexadecimal value, this value. This value may not be a real Unicode character, but just for the sake of example we are taking it, and it will help us to see how to encode the values. So the number is greater than FFFF, so it will require how many bytes? 4 bytes. I hope you'll be able to do for 1 2, and these 3 4 bytes may be some typical, so I'm taking an example of 4 byte encoding. So let's see how this actually goes. We have the binary value of 1 F A C B D. So 0 is 0 0 0 0, 0 is 0 0 0 0, 1 is 0 0 0 1, F is 1 1 1 1, A is 1 0 1 0, C is 1 1 0 0, B is 1 0 1 1, D is 1 1 0 1. If you don't understand this, just refer to the table I discussed earlier. I've just taken the binary or the binary equivalent of this F. Now it is written right. Now we need 4 bytes. So I'm just writing 4 bytes for Unicode, and in this 4 byte we know that this 1 1 1 1 0 will always be fixed. This 1 0 will be fixed, 1 0 will be fixed, 1 0 will be fixed. So how many we are left with? Of course 21 of them are with us. So let us take this one, 0 0 1 F A C B D, as we just explored and maintained it in the value of binary digits. Now this is what we are going to do. This is our Unicode, and now just place these values 1 0 1 1. Now this is 1 1. Now this goes here, 0 will go here, 1 will go here, 0 0 1 1, then 1 0 1 0 1, then 1 1, then 1 1 1. Okay, and rest 0 will be just ignored. So this is how we come up with the original value what we have started, and this is in UTF-8. So if I want to write 0 0 1 F A C B D in UTF-8, it will be F7 B A B2 B D. See how simple was that? It was fairly straightforward.